Hi everyone, my name is Liyan. Today I'm going to demonstrate a standardized performance testing framework and its enabling solution I built together with two colleagues, Chang and James, within Capital One, and we named it Vega. So myself has been working in performance engineering and the performance testing area for 10 years, and I observed some common problems in performance testing practice from different organizations and across various LOBs. To sum them up, like their lack of proper understanding of performance testing goals, their lack of standard performance testing process, and also the existing solutions are mostly ad hoc, inconsistent, and non-economical. So our goal is to implement an effective, efficient, and economical approach to build performance into the software development. Vega is built to help us achieve the goal. We call this framework a performance testing framework, and it consists of two parts: an established the performance testing standard and an enabling platform to facilitate the adoption of this standard. So first, let's just take a quick look at the standards. Here, we want to establish the standards by answering three essential questions related to performance testing. What should performance testing care about? How to correctly capture core performance testing metrics, and what are the most suitable performance testing toolkit. Because of the length of this demo, I will not dive down to the details of each question. We have built an enabling platform which uses the answers to these questions as the fundamental guidelines. So I will demo the enabling solution shortly. A quick overview of the enabling platform here. Basically, it's a self-service performance testing platform that provides you an integrated testing infrastructure and gets your performance test running in just a few seconds. Some core functionality of the platform are the managed testing infrastructure. Basically, a Docker container will be started upon the test request and terminated right after the test. The real-time monitoring and dashboarding. The user is always synced up with testing status from the first second after the test is started. Historical data analysis. In Vega, we provide a graphical insight on the trend of any of your tests and comparing them to the SLA or the target goals. The CI/CD pipeline integration. It's a collection of RESTful APIs for easy CI/CD integration or for integration with any other applications. Now let's go in for the demo. This is the homepage of Vega, and for user connects to the Vega for the first time, they just need to log in through the GitHub authentication. The default page here is the test summary. Since I log in for the first time, nothing will be rendered here, and we can start from creating some test projects at the Add Project page. Here, we can either add new projects or follow some already added projects. On the left-hand side of the page, it lists all the GitHub organizations my account is part of. Selecting Vega, I can see all the repositories associated to that organization. And if you have a new test to add, like Vega Demo 2 here, you can click the Add Project button to just quickly add the test into your test management profile. And if you recently joined a team and which has some existing testing project already, then you can also quickly just click the follow button to follow those tests and keep this under your radar. And if you move out of the current team and no longer need to manage this test, you can of course come here to unfollow this project afterwards. Now, when I move back to the test summary page, I can see the projects I just added or followed, as well as all the corresponding tests associated with each project. And on the right-hand side panel, we can see the historical test runs and some very useful information associated with each test run in a table format. You can see whether this test is successful or failed. You can see the name of the test and the project it belongs to. And here we have some cool feature we call analytical metrics. We calculate for your convenience. So without going into details or being directed to other places, you can see a comparison of the response time and the throughput to the corresponding SLAs. And we can extend these analytical calculations to other metrics like CPU and the memory usage of the test. The dashboard button comes in handy if we want to dive into low-level details of the particular test run. And we automatically create this dashboard during the test execution process. So clicking on that will take us to the corresponding Grafana dashboard. Grafana is a third-party open source tool we use to visualize our testing data. As you can see, Grafana dashboard here illustrates lots of testing metrics together with monitoring data, which will enable us to do some performance problem troubleshooting. Also, due to the limited time we have today, I will not go through each graph here. The last column indicates when the test is executed and the duration of each test run. Now if we click on a particular test, it will help to filter out other testing results from the summary table. And more importantly, it enables us to run the test, schedule a test, or create and edit a monitoring configuration associated with this test. Oftentimes, performance tests need to be done during off-work hours, or it's a repetitive effort to run the same test frequently. Scheduling comes in really handy to handle these scenarios. We can schedule the test for a dedicated date and time in the future, or just click the repeating checkbox to make a test reoccurring to help us avoid the hassle of manually running the same test every time. Now just let's click the Run button to start the test right away. The test execution window will pop up. We can here check and tweak the test load design and enable or disable the monitoring for the test. Click Run to trigger the test, and now we can see a new job is added on top of the table with status queue. Click this link here will get us to the job detail page from which we can check the status of the ongoing test. As you can see, the status is changing from queue to running. The queue means behind the scene we are launching the Docker container. As you can see, it launched really fast in just a few seconds. Now the test is being executed and running now. And since performance tests usually will use a dedicated load simulation instance and take fairly long time to execute, one question I got oftentimes is how do I know if my test is running properly or not after I kick it off? So this job detail page is exactly the place where we want to answer questions like that. As you can see, it tells us the status of the test, when it is started, ended, and what I like the most on this page is it provides us the console output streaming directly from the load simulation instance. So we will always sync up with the latest test status. Another cool feature I want to show is the Insight page. By selecting the project we added or followed, a performance trend analysis will be graphically presented for all the tests associated with the selected project. In the trend analysis, we currently focus on two essential performance metrics, response time and the throughput. It illustrates the performance trend of the previous 25 test runs for the particular test. Starting from the right is the latest test execution. The gray line in the graph represents the SLAs. So response time slower than the SLA and the throughput lower than the SLA, they will be marked red for your alert, for your awareness. And if we move the mouse over the bar, a tooltip will pop up indicating the test run number and the corresponding metric value. Last but not least, the documentation button. It will get us to the Swagger page of the Vega platform. Here we list all the open API we support at the backend. and also how to use this API as well as the format of returned JSON response. This greatly enables Vega to be easily integrated with any CI/CD pipeline or other applications. Thank you all for watching. This is the end of the demo.